Hello guys, welcome to another video, and this one is going to be a little bit technical. We're going to talk about a mathematical term called the dot product, and you may have encountered this before, or not quite understanding it. And this one I'm just trying to simplify it so that we're not going to talk about how it's calculated specifically, but we're going to talk about its geometrical meaning. And that's actually what's more important, because in most of the cases, no matter if you're using Houdini or Unreal or Unity, the function is already implemented, it's encapsulated already for you to use. So you don't have to know that. You don't even have to know like how it's calculated internally or any other twist it may have underneath. The low-level stuff is already done, and all you have to do is know how to use it properly and what does it mean to do dot product, right? So I'm gonna go create a line here to represent like an vector. It's sitting on the origin and it's going up. I'm gonna make it pointing towards the x direction instead, like that. I'm gonna call this one v1 and have a copy of that, and it's gonna be v2 here. And let me create a transformation node. And then I'm gonna rotate this guy maybe 45 degrees for now. Okay, and then I'm gonna do a merge to merge those two lines together. Now, like what I said before, I want this one to be a vector and this one to be another vector. Now, because they are all started from the origin, that means the coordinate of point 1 and point 3 is basically the two vector I wanted to use here to do dot product. Alright, so to do that, I'm gonna go create an attribute wrangle here, and then here I'm gonna change the run over to details, so I'm gonna run it only once, and so this vector will be v1, right? Vector v1 will actually be the coordinate of point 1. To get that, I can use the point function to ask the position of point 1, and this 0 means we're basically asking the first input of this wrangle node, because there could be multiple inputs. That 0 means this one, basically this, and we're asking the position of point 1 out here, and we can also go ahead and get point 2 or v2. Actually, this time we're gonna get point 3, right? That's that one. Okay, so to calculate dot product, we can say float attributes dot results will be equals to dot, which is the function already done, right? v1, v2. And then control enter to run this. You can see now we're getting a result here in the details panel. Sorry, not details panel, in the geometry spreadsheet. We can, in the details, we can see now the dot result attribute is created and its value is 0.7. Alright, so the dot product of this vector and this vector is going to give you the value of 0.7. And just to be able to check various different angles, we can go ahead and create an attribute and call this guy degree. And degree is here, and then accept that. I'm going to copy that parameter and then use that to actually control this rotation here. So right click here, I'm going to say paste relative reference. Okay, so now I can go here and drag that thing, and you can see I'm able to change it. Although it's only going from 0 to 10, so I'm going to change that range from 0 to 360, just to be able to drag all the way to, go through the whole span of possible angles. Alright, so let's take a look at the values we're getting. So now degree is 0, and we're getting the dot product as 1. Okay. Now let's drag it up. So now the degree is a little bit bigger. You can see the value is getting something smaller than 1. The further we drag, the smaller the value is, right? And when the degree is exactly 90, meaning that those two vectors are perpendicular, we're getting a value of 0. And go beyond that, when they're facing away from each other, we're getting a negative value. And then all the way to completely offset, negative 180, the value is actually negative 1. And when we keep on going from there, like maybe to 13, right, you can see the value are starting to get bigger now, right? Gradually getting bigger from negative and all the way to another right angle to 70. You can see how it becomes 0 again, Again, those two are perpendicular now, and keep on going from there all the way to back to the same direction that the value becomes 1, right? So basically, as you can see here, the dot product somehow resembles the angle between those two vectors. If they are the same, then value will be 1. If their direction are facing further away from each other, the value will get smaller and smaller. The smallest value when they're facing away completely is going to be -1. Any value is going to be bigger than that, right? Cool. So this is really useful because, oh, and also one interesting feature is that when the degree is like 90 degrees, you're getting 0, right? This can be really useful because when you want to check the direction of two vectors, you can use dot product. And if the dot product is going to give you, if the dot product gives you a value of 1, that basically means the two vectors are facing the same direction exactly. If the dot product is 90, that means they are perpendicular. If it's -1, if the value is 0, right, that means they're perpendicular. If the dot product is -1, that means they're facing away from each other like completely 180 degree, right? That can be already really helpful when you want to check things like recasting or whatever, or moving points around basically, right? But it's not just that. The actual value of this dot product, of course, we're all talking about this when the two vectors are having a length of 1, so unit vectors. It's not going to be the same value when you're not using unit vectors, but we can talk about that later. But for now, in the context of just unit vectors, the value will be exactly like that. Okay. Anyway, and we can use this to compare the directions, but not just that, you can get exactly the angle here by doing dot product. Okay, because mathematically this dot product is also actually the cosine value of this angle those two vectors are having. Okay, now you don't have to know how exactly that's proven mathematically, you just have to go through some trigonometries and sine, cosine stuff to actually prove that that's true. But you know, that's not the point here. We're not going to prove it, we're just going to use it. And so yeah, if I know the dot product of two vectors, I can calculate their angle. To do that, you just need to use the reverse A cosine. As what I stated earlier, the dot product is the cosine value of the angle between those two vectors. You run that through the reversed function here to get the angle, and then you can see the result here is 0.5. Of course, this is radian, so we can convert that into degrees by doing the degrees function. And you can see the value is 33.4 degrees, exactly the value we're having here, right? How cool is that? So basically, if you can calculate the dot product of the unit vector of any two vectors, you're able to use the reversed function and some conversion from radian to degree to get the actual angle between those two vectors, right? So yeah, that's basically, you know, a very important and powerful way to use dot product. Okay, so if the lengths of the two vectors are not the same, let's say 2, okay, and let's take a look at the result. We're not going to convert it into degree anymore. Just take a look at the result of the dot product. You can see we're getting, if the degree is 0, we're getting the number 2. Okay, and then keep on going to maybe there, you can see we're getting 1, and it's still going to follow that same nature. So when they're close, when they're facing the same direction, the value will be the biggest, and when they're facing completely away from each other, the value will be the smallest. But because their length is different, if the length is different, right, not unit vectors, this small and biggest value will be varied. Okay, that's basically all the difference is. And that value you're getting is actually also very interesting. That value, let's take a look at that. It's 1.07 here. Maybe make it maybe a little bit bigger, 1.4, right? That value is actually exactly, in this context, of course, is the x coordinate of 0.1. Let's take a look at that. 1.43139, right? The same position, the position x, or the x coordinate of the position here for 0.1 here is exactly the value of the dot product here. So what that means is that in another context, the value is going to be the shadow captured from this vector to the other vector. Okay. All right. And of course, you have to. Oh, that's actually not just that. It's not just the shadow, and also times the length of the other vector's determinant, or the length, basically. Right. So yeah, that's what that is in another context. But it doesn't really. It's not something new though. It's basically still the cosine alpha, and just added that extended length, or scaled by the new length that you're having if they're not a unit vector, and that's all there is. Okay. Yeah. So yeah, this is dot product, I think, in its full extent, to the way that I use it mostly. But maybe there's some other things. When it comes to mathematics, it's never going to be just one concept, right? The math is not designed to describe one thing. They're pretty abstract sometimes, and sometimes they have dual or even multiple meanings while putting into different contexts. So this is just geometrical wise, right, how we understand it, but it can completely mean different things in maybe accounting or whatever. Anyway, so yeah, that's it for dot product. Thanks for watching. See you next time.